Okay, so we want to draw the Lewis structure for nitrates. So let's go ahead and start off by counting our valence electrons. I got 5 valence electrons from nitrogen. I've got 6 from oxygen, but there's 3 of them, so that's a total of 18. And now nitrate also has a charge, so that means there's 1 extra electron, so I need to add that one to the mix. So it's 6 plus 18. I should come up with 24 valence electrons. So let's draw the Lewis structure. Let's take it nitrogen, oxygen, oxygen, and oxygen. We know that it's nitrate, so it should end up being charged. So I want to put a bracket around it, and I want to represent that to the reader that in fact there is a charge there. So the next thing is to draw a single bond between each of the central atom and each of the oxygens. And then I want to reduce my electron count by the 6 electrons that I used to do that. So I have 18 left. And now I want to make some lone pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's all 18 electrons. It looks like nitrogen does not have an octet. Well, what do? I take a lone pair of electrons, I erase it, and I use it to make a double bond. So now nitrogen has an octet as well as all of the oxygens. But remember, I arbitrarily chose the oxygen that was up and to the right. I could have chose the oxygen up and to the left. Likewise, I could have chose the nitrogen or the oxygen that's pointing down. All of those would have been equivalent choices. And so all of these options would be correct for the Lewis structure. This is an example of when there's resonance. So nitrate actually exists in resonance. And if we were to think about it, what that means is that the real structure is a combo. It's a combo between this one, and this one. And so what can we say? We can say that, well, probably since there's a double bond in every location between the 3 structures, we probably have some situation where there's a partial bond in the real structure. And so, for instance, in this case, we would expect that all NO bonds are equal. That's one thing we would expect since it's an equivalent resonance structure. Okay, let's talk about the electron geometry. The electron geometry is trigonal planar. Doesn't matter which one we look at. There's 1, 2, 3 geometry groups. There's no lone pairs, so the molecular geometry is also trigonal planar. We know that with trigonal planar geometry, the bond angles work out to be 120 degrees. And since it's an ion, we're talking about something that has a charge. The polar versus non-polar thing is not applicable because, again, it's got a charge, and polar means separation in charge, specifically a partial separation in charge. And this molecule is fully charged. So that question about whether or not it's polar or non-polar doesn't make sense for this particular structure. Okay, that's it.